Thank you very much. So we are going to dive right in. I've got a fast-paced bit of content here with some live coding coming up. So I want to kind of get through content here. So I'm going to talk about building Java applications with Neo4j. And my contact information is down there in the lower left-hand corner of the slide. I'm almost positive it's on the very last slide as well. So don't rush to try to jot that down. It'll be available at the end as well. And then I'm happy to share that, whoever would like that if you forget later. But please do feel free to, if you think of something even past the Q&A chat here later, feel free to contact me. Any of those methods there are good. I'm reachable. And so I'm happy to continue the discussion or answer questions at any time. All right, so just a very brief background on me. I'm a developer and I enjoy learning, and then I enjoy sharing that learning in a variety of ways, whether that's through blog posts or speaking at events like this. And then of course I have several other hobbies as well. I love, cats and coffee and traveling and Star Wars and all those wonderful sort of things. And they basically all boil down to I'm a geek in one form or another, and I kind of enjoy that. So that's just basically me in a nutshell. All right, so let's talk about what actually is graph. This is a very formal definition. Don't get worried if there's a lot of, kind of confusing language there, or you don't quite comprehend all of that. That's fine. We're going to walk through all of this, and hopefully here in just a few minutes, you'll have a much easier understanding of this. So graph is formally a set of discrete objects, each of which has some set of relationships with other objects. This was actually, it's not new, even though graph technologies are relatively new. This whole idea of graph is not new. It starts all the way back with Leonard Euler, who was a mathematician, scientist, and many other things back in the 1700s. And he wanted to solve the problem of the seven bridges of Königsberg. In the city of Königsberg, Prussia, there were 4 land masses connected by 7 bridges, as you can kind of see in those 2 left images there at the bottom. And he wanted to answer the question, can I access all 4 of these land masses, cross each of the 7 bridges, and come back to the starting point without duplicating? And so this study and research became the foundation of what is known as graph theory. So you have kind of entities or blocks, in this case, land masses, that are connected via relationships or lines, pathways, basically. So graphs then show how data is connected. For instance, we have this image here. We have people, entities in blue. We have kind of technology entities in green. And then we have company entities in kind of a reddish orange there. And take, for instance, one entity there. The center node entity is Jennifer, which, yes, it's named after me. But we can get a better understanding of Jennifer's network and the things that Jennifer's world operates within by looking at the relationships, and then the relationships of relationships, and so on out. So you have several people she's connected to, in fact, not just connected to, but is friends with. She likes a few different technologies. She's connected to one company, but then we can start to see, okay, if we go out to her friends, what companies is she connected to 2 hops out? What might be, potential technologies she might use in the future, or things people might introduce her to, et cetera, based on the things she's immediately connected to right now. So just taking some couple of really silly examples, and then a couple more business related ones. Have you ever walked into a room, forgotten what you needed, left a possession somewhere, you can't remember where, written a code or requirement, forgotten why you even did it? And then taking kind of maybe some more business application use cases, not sure where a bug or an issue is coming from, so you're trying to track that down. You don't know the impacts of a device or system being down. You're unsure how your customers relate to your orders, or maybe your employees, or who knows what, or the products they purchased. This is where graph comes in. This is where graphs excel. It helps you trace steps. It can document a pattern or a pathway, not just the data at a particular point in time. It tells you how and why something might be the way it is, or how it's operating, not just who, what, and where. It helps you understand the connections. So what are maybe alternate routes or impacts based on certain pathways in my network? Maybe those pathways aren't available anymore because of X circumstance. Okay, how do I understand better other options that I have. This gives you better assumptions and better decision making in businesses, because obviously if you have something that these patterns, maybe you want to explore one pathway or another pathway, or like I said, something might go down and you need to explore the alternates. It gives you better options for better decisions because those paths are already there. They're already being mapped out. So let's take just a quick example here. Let's say we have you and this person you might want to become friends with. Now, you could become friends with this person for any sort of motives. You might want to sell them something. You might want to mimic their success. You might want to just be a good friend or just want to connect with this person because you think you have a lot in common. But how would you go about becoming friends with this person? Well, probably, without even probably thinking about it, you have these things that you like to do or things that you enjoy or topics you know a lot about, etc. So you kind of have this little mini graph around yourself of things that make up things about you. And then when you want to get to know this person, you somehow interact or talk with this person and you'll find out things that they enjoy, and they may not always overlap. Maybe they're topics you might want to learn more about, or maybe they're topics that don't interest you at all. And then you'll come across things that you actually have in common. So things like music, coffee, pets, and food, all of those are things that I really enjoy. And hopefully my prospective friend would as well. But this gives me then topics and connections and relationships that I can build upon, because then, okay, they like music. Maybe I might want to give them concert tickets, or maybe I want to go to a concert with them because we both enjoy this certain thing. Maybe I can sell them coffee better because we both understand coffee. We both enjoy it. I have a deeper connection, maybe a better relationship with this person because we both like and know a lot about this topic. Or maybe since we both like food, maybe now we can go cook a meal, or they can show me how to cook this, or I can show them how to cook that, or maybe something to go out to dinner and try a new restaurant in the area, etc. So all these relationships, anything that you have connections with, then gives you better ideas for other things, things you can do, things you can buy, things you can help them with. Let's take another example. So you come home from work at the end of the day, you're out on your balcony, maybe sipping a nice cup of tea or enjoying a piece of chocolate cake, and you're trying to remember, where in the world did I set this thing down? Maybe I had a bag or something, my work bag or what have you, that I set down and I can't remember where I set it down. So what you typically do is you start tracing back through what you've done. Okay, I went to the closet to hang this up. Okay, I went over to pet the dog near the kitchen table. I came in the door. Oh, I dropped my bags when I came in the door because I had my hands full, or my dog was jumping on me, or maybe I had to answer a phone call, etc. I dropped everything right at the door. That's how I know where this was. So again, tracing that path, figuring out maybe what occurred before when, or why something might have occurred. So let's take something a little bit more serious now. Those were kind of more fun use cases. But in business, graphs are being used for things like social networks. So understanding how people form relationships, or maybe how those relationships break apart. And this doesn't have to be necessarily social media. It could be workplace, it could be teams, it could be lots of different things. Fraud detection, so not only understanding users, but now also their financial data around them, and trying to figure out what are abnormal patterns or unusual things that people are doing with their finances that maybe look suspicious. So for instance, in this small graph here, you have a few users sharing social security numbers. That's obviously a red flag. But then you might have some users maybe sharing an address, but then passing thousands or millions of dollars back and forth. That also looks suspicious. So analyzing users, their financial habits, and then trying to see what are the abnormal cases that you might flag as potentially fraudulent. This one I like because it's a physical representation of a graph. So networking and IT operations, this is kind of mapping out your devices over maybe a building or a campus or a home or any place. So understanding how physical devices are connected with physical wires, when something might break or need upgraded, the status of everything, and maybe kind of an overall view of, or map, if you will, of your data IT devices. And then identity and access management, I find this topic very confusing anyway. I've had several cases where it's been like, oh, I have this particular role. I have access to this resource, but why do I have access to this resource? Where did this come from? And so Graph helps you trace back through, okay, this role was granted by this person. This role has direct access to these three things. Oh, but this role also has access to these three things plus this other thing. And so Graph helps you trace back through that and understand where the stuff is coming from better. And then finally, where a lot of graph technologies got their start was in graph-based search. So how can I provide better search results, better recommendations through things that users are searching? Okay, so let's look at the actual structure of a graph. How do you build one? Graphs are known for being whiteboard friendly. So typically, at least when I have a new technology problem or a new domain, I'll sit down to a whiteboard or piece of paper and draw it out. Your process flow, what data might be coming in, et cetera. And that's exactly what I've done here. And this is a model of Java version data. So I have Java versions, I have diffs between the different versions, and then I have kind of sub changes within those diffs. So things like packages and classes and fields, et cetera, in the Java language. We're actually, when we write our Java application, we're going to focus in on just the Java version and the diff on the left-hand side of that. But this is kind of the full model that I drew out. And then you might formulate that into something a little bit nicer, a little bit neater, go to a modeling tool or some sort of drawing tool. That's what I've done here. You can show this to maybe management or your business users or your colleagues, et cetera. And then when I actually get ready to store it in the graph, this is what it looks like in the graph database. So notice then how excessively similar, actually exact, it looks to the way I drew it on the piece of paper in the first place. So this is what's known as being whiteboard friendly. Your model looks very similar or exactly the same in the database as it actually does in the real world, as you would draw it on a whiteboard. Okay, so what are the pieces of the graph? What's kind of the lingo and all that? So you have your entities or your nodes in the database, which if you're a mathematical background, these are known as vertexes for graph theory. These are your objects. So kind of your nouns, person, place, thing, object, idea in your domain. Then you'll have relationships or mathematically edges, and these are your connections. So these help give context to how your nodes, how your entities are related to one another. For instance, we have our two people, Jennifer and Michael. Not only do I know, Jennifer and Michael are connected, maybe they just met in a coffee shop, maybe they shared an Uber ride, maybe they went to the same conference. No, we actually are saying they're actually friends here. They're connected via a friend relationship. So that gives me ideas for maybe who I want to talk to or connect with or get resume references and so on, because I know these two people have this kind of relationship. Okay, so now let's look at how we would develop applications with this. There's a variety of ways to do this. I'm just going to show kind of one that I'm most comfortable and familiar with. Feel free to, if this is not your preferred method, go out and check out plenty of others. We're going to use the Neo4j Java driver, which is an official driver. And then we're also going to use Spring Data Neo4j, which is Spring Data's integration with Neo4j. And that uses the Java driver at the base. So I don't have to specify anything separate. I can just use Spring Data Neo4j, or SDN as we term it. And that includes the Java driver for me. There are plenty of other options. Like I said, we have plenty of official drivers for various languages like Python, JavaScript, Go, .NET. And there are some others out there as well that I haven't listed here. But then there's also plenty of production ready and used community built drivers. So partners, community users, customers have built their own drivers for various languages, and those are out there and available as well. If you're not a Spring fan or not familiar with Spring, there's other Java frameworks that we integrate with too. So things like Quarkus, Helidon, Micronaut, again, check it all out. There's plenty of them. So whatever your preference, feel free to take a peek. All right, so one of the reasons I'm using Spring tonight is that Spring gives me a lot of stuff out of the box, which makes it really easy to demo this evening, especially in such a short time. Spring Initializer is one, which I'll show here in a minute. Spring Boot does reduce some of the boilerplate for getting an application up and running, which is really nice. There's annotation-based object graph mapping for your plain old Java objects. So if you're familiar with ORM, which is object relational mapping, which is basically a framework that maps your database to your application objects, This is basically the graph version of that. And then Spring provides query derivation. So some kind of pre-built kind of provided out of the box queries like find all, find one, find by ID that pretty much everyone's implementation is going to be the same for. So they give you those right out of the box. But then if you want something specific or you want to tweak those, you can absolutely write domain specific language or DSL for your custom queries. And since we're using Neo4j, Neo4j's query language of choice is Cypher. So that's what we're going to see. And then Spring Data has a lot of easy ways to connect to Neo4j. There's Bolt HTTP or an embedded methods. I'm going to use Bolt mostly because that's the standard and most performant for today. So, all right, let's jump into our demo. So I'm going to hop over to, where did my window go? Oh, I love when this happens. Not. One moment. There we go. Okay. So pop over to Spring Initializer here. So it's just start.spring.io, and it's going to give me a couple of kind of options. So I'm going to choose a Maven project for today. Java is my language of choice, at least for now. Spring Boot, this is the standard version. I'm just going to kind of organize my project structure for my own personal needs. So that, and we're going to call this coffee matrix. And we're going to leave it as a jar, and Java 11 is kind of the standard. And then I need to add a couple of dependencies. So the web dependency is going to give me REST API capabilities so that I can interact with my data via a REST API. And then I need the Spring Data Neo4j dependency as well. Just going to generate this. It'll drop it into, let's just drop it into downloads for now. Good. I can unzip that and open that up with my preferred IDE, IntelliJ, switch over to, oh, it's not wanting me to do that. Okay, well, oh, there it goes. Okay, it's still loading. That's what it was doing. Okay, so as the project loads, I do have a Neo4j database in the background for this. I don't know why IntelliJ has been doing this to me lately. And I'm running Neo4j Aura, which is our cloud Neo4j provisioned database. If you have more questions about that, feel free to ask me afterward. I'm happy to talk at length, but it's a free database. Anyone can sign up to get a free database. You just need your name and your email address. And it's Neo4j provisioned and good for like proof of concept projects and hobby projects and exploring and all kinds of good stuff. So feel free to check that out. Okay, so I have my project structure here, and you can see this is my POM. And it gives me, Java 11. I have the 2.5.6 version of Spring Boot, and then the Neo4j dependency and the web dependency, which is going to be my REST API. And then it includes a test dependency for me already, and then the Maven plugin for building everything. So that's pretty much all it's going to give me. Now, I want to set up some properties for connecting to the database. So I'm going to use the URI, and I'm just going to set a few variables to fill this in so that I'm not sharing valuable kind of identifying information here. For my connection details, be a good citizen and don't share that stuff, right? So Neo4j, username, and this is just to connect to the database. So nothing really fancy here. Neo4j, password, Neo4j, and choose the database. And Neo4j supports multi-database, so therefore I need to specify a specific database to go to. Now I can set up these configurations here to put these parameters in. So Neo4j URI and Neo4j username and Neo4j password. Okay. Now, doing this, I'm going to stop my share for just a second. Don't worry, this is purposeful. And I'm going to slide over and just enter my username password details so that I'm not sharing that with all of you. But give me just 1 second. But a little bit on Neo4j Aura while I'm kind of waiting here. free database. There are other tiers. And again, I'm happy to share that. So if you need something, paid tier or more support, things like that, we do provide that. But the free tier is open and available, and it's super nice for this kind of stuff. So I'm really enjoying it quite a bit. So let me switch here, back to Zoom, back to share my screen. Okay, and back to IntelliJ. Okay. So hopefully that worked okay for everybody. All right, now we're ready to start building some classes here. So we have our Java version. If you remember the data model, we just have our versions and our version diffs that we're going to focus on today. So I need to tell Spring that this is an entity type in my database. So I'm going to use the @node annotation. I need to tell it I have an ID field, and then this is a private string Java version field. And then I actually did an oops when I imported the data into the database. I just named my property version in the database. So I have to map it and tell it, hey, look for version when you go to the database side, but I'm calling it Java version on the application side. So that's all I'm doing there. And then we'll have a couple of string fields. So name, code name for a Java version, the status of it, and then an API spec. And I believe that's a link for that, but we're going to leave it as a string. And then I need to pull in my constructor and use some getters for all of these. Oh, there we go. Now that looks pretty good. Now let's go over and we will add our repository class. So this allows me to connect to database and have some methods that connect. And let's see, we need to extend the Neo4j repository, and we have an entity type Java version, and the ID type for that entity is a string. Now that's actually all we need to do, because we're going to utilize the out of the box derived methods that Spring provides, like find one, find all, etc. So we actually don't have to specify any methods. Oop, I need to stay there and go over here. Now I just need to specify our REST API. So Java version controller, create a controller class. This is a REST controller. Need to set up a mapping, so basically an endpoint. And then I need to inject my repository. Oops. Repo, and then it wants a constructor for that. So let's do that. And then I can specify a particular endpoint now to hit and get specific data back. So for this instance, I'm going to just use an iterable of Java versions. So multiple Java versions coming back. We're going to call this find all Java versions. And we're going to do a return Java version repo dot find all. Now remember, I didn't implement the find all method in my repository class. Spring kind of provides this out of the box because most people's find all method is going to be pretty much the same, right? You're going to look for all the objects. So that actually puts us into a really good spot where we can run this thing and see what we get back, assuming everything's going to operate correctly and I've sacrificed enough to the demo gods. But while that's working, we'll hop over to our browser. That's looking like that's going pretty well. Oh, did it not switch on me? Didn't. I may have to get out of full screen mode here and go back to. Oh, that's lovely when it doesn't work. Okay, 1 second. Alrighty, so let's open up. Do localhost port 8080/versions. You can see I've tested this recently. And when I get here, I'll zoom this up so it's a little bit easier to read. Hopefully that is better. But we have our versions, we have the status, code name, the API specs, etc. You can see all the way up through Java version 18, which actually is not currently released yet. We just released Java 17 back in, oh, and I didn't add the dates on that, back in September for that. There are a couple of date fields that I forgot to add there, but okay, with that, let's go back to IntelliJ then. You might say, hey, that's great and all, but you haven't built any graph stuff. You haven't done any relationships or connections. You are correct. Let's fix that problem. Oh, I keep wanting to do the wrong shortcut. Okay, so let's go over and we're going to do our version diff class now. So this is another node. We're going to use an ID. This is a generated value because I didn't really have a good business key for this. So what I've done, which is not great practice, is I've used the internal Neo4j ID for the node. Again, not great practice, but that's what we're working with for tonight. So, and then we have different vendors that release Java versions. And then our 2 vendor and 2 version here. So again, we have different vendors and different versions of Java. We're going to diff between them. And so we're going to use all these fields. And then our constructor, put in our getter, all those things. Okay, great. Now we still haven't done anything super graphy yet. So again, we're going to fix that because we need to tie these entities together. We're going to do that with an at relationship, and we're going to say from newer, and then list, sorry, version diff, that's what we need. Import, and then because we're coming from a Java version, we're coming from a newer Java version to a diff. So you're going to be looking at older versions, right? So older version diffs. Then we could do the same thing going the other way. Maybe we'd want to look coming from an older Java version, what's new in the latest stuff. So we have a from older relationship out there as well. Private list, version diff, oops, not version diff. And these are newer version diffs. Okay, and then we need a couple of getters for these guys. Those. Okay, and this puts us in a good spot. Then we should be able to rerun our app. And I'll be pushing time just a little bit because I want to show one more thing in the demo before we pop back over and I give you guys links for everything. Okay, that's looking good so far. And of course, that's not going to cooperate with me. So we can fix that. Okay, there we go. So let's reload our endpoint here. And now we should get the relationships of Java versions connected to all the version diffs. Now in 1.0, the data that I have that I imported doesn't actually tie any version diffs to 1.0. Not sure why that is, but it's a data problem. So starting at 1.1, then we actually have some values here. Nothing older, of course, because they're not comparing it to 1.0. But you have 1 compared to version 5, you have 1 compared to version 12, etc. And we could go on down to something newer where we could look at this a little bit better. Let's see, there's Java version 12. So we've got against 10, against 7, against 2, and on down. Then the newer ones, 12 to 16 to 17, and on and on. Okay, so let's jump back here and do one more small thing. We're going to, maybe that's a lot of fields coming back. Maybe you just want to skim this down quite a bit. So we can actually write a Java version projection, a projection class, or an interface in this case, where we want to say, okay, we want to do just the string get Java version, that, and then let's do a list of, we're going to write another projection. So this is basically a nested projection. And we're going to call this list diff projection, get older version diffs. And then we need to write that diff projection. We're going to do that here. So basically, I'm just projecting, creating what kind of like a view with a small subset of properties that I want to get. So version like that. And then I need to actually use this. So I'm going to go over to the repo. I'm going to write a custom query. So again, since this is a projection, the Spring derived method or finder method isn't going to capture this. So then I can go in and write my own and be very specific. So I'm using Cypher, which is Neo4j's query language. I'm just going to input some stuff here. This is basically the same query that I had before. It's just now custom. I'm doing the writing of the query. Collect row, collect D, and then we need iterable Java version projection, and we're going to call this find all Java versions so that I have a little bit less typing to do here in just a second. Okay, that looks good. Let's go back to our controller, and so I need to change this to the projection. Java version projection, and then of course it doesn't read this, so find all Java versions. Now it should be happy. So let's rerun our application and let's see what we get back. All that is going there. I'm going to switch here, pull up the right window, and reload this. So then I should get basically a view or a very small subset of entities here, which is exactly what I have. I have the Java version and I have older version diffs. Again, 1.1 isn't compared to anything older. And I didn't pull the newer ones because I told it not to in my projection. So we have 1.2 to 1.1, we have 1.3 to 1.1 and 2, etc. You can go on down to, the newer ones, etc. there. So all that is looking good, and that's pulling back exactly what we want. So let's wrap up then and just show a couple of resources. So this is all the source code that I wrote and demoed this evening or this afternoon, wherever you might be in the world. So feel free to check that out. I do also have a couple more links within that repository that connect to more full-blown applications that kind of include more of that data model that I showed in the beginning of the presentation. If you're curious about Spring Data Neo4j, the documentation is there. Not only does Spring Data Neo4j have an imperative support, but it also has reactive code support too. So if you want to check out a sample application that I wrote there, feel free to look at that third link. And then finally, if you're curious about the Neo4j hosted database as a service, RADB, that last link is where you want to go for that. And again, my contact information down there in the lower left. I will be in the chat to answer questions. Thank you guys so much for watching, and I hope to see you in just a minute.